All right, so there's a couple questions from section 2.3 that I just wanted to go over very quickly. So the first one is number 7. They give us the function 3 minus 3x minus x squared all over x squared minus 5, and they ask us to find the derivative. So the first thing you could try to do, of course, is simplify. So let me put this in the correct order. Negative x squared minus 3x plus 3 divided by x squared minus 5. But I'm pretty sure that we're not going to be able to factor anything out of the numerator or the denominator other than the negative sign. So I'll make this a negative fraction, negative x squared plus 3x minus 3 all over x squared minus 5. Right? And you don't have to do that, but it might make taking the derivative a little more simple. So now we can take the derivative, right? And we're just going to use the quotient rule. This is u over v. So the derivative is going to be v du. I'll use u prime for the derivative. It's a bit of notational abuse there, but I think that's fine. vu prime minus uv prime all over v squared, right? Okay, so yeah. Oh, don't forget the negative in front. Good enough, I guess. Just trying to erase my previous mistake here. All right, so f of x equals negative. So let's see, denominator is just x squared minus 5. Numerator, the derivative of the numerator, is just going to be 2x plus 3. And then minus the numerator, x squared plus 3x minus 3, times the derivative of the denominator, which is just 2x. And then divided by the denominator squared. And there's the derivative. Kind of a mess, so I think we can simplify it by multiplying out the numerator. Again, I'll leave the negative in front. So this will be a FOIL, 2x cubed plus 3x squared minus 10x, and then minus 15. And then minus, so we're going to get 2x cubed, and then 6x squared. It's a positive, but then there's a negative in front, so that's negative 6x squared, and then positive 6x, right? So negative 6x. And there's no reason to multiply out the denominator. I'll leave it as x squared minus 5 squared. So there's a few things we can do in the numerator. You should notice that 2x cubed minus 2x cubed is 0, so that adds up to 0. And then we can do 3x squared minus 6x squared, so that'll leave us with a negative 3x squared on top. And then negative 10x plus 6x is negative 4x. And then the minus 15. All over, same thing, x squared minus 5 squared. And now we can distribute the negative 1 in front. Again, we don't have to, but it makes it look nicer. It's 3x squared plus 4x plus 15 all over x squared minus 5 quantity squared. And that should do the trick. I don't think we're going to be able to factor the numerator here. I guess it's possible, but it's just not likely. So I would leave the answer like this. Okay, so number 9 is also a bit of a tricky one. F of x equals 2x cubed plus 3x times x minus 1 times x plus 4. And it just says find the derivative. So Right, so there's a couple of ways we could do this. One way is to treat this as a product and use the product rule, right? This could be your u, this could be your v, and then this factor would be w. So we're essentially taking the derivative of u times v times w. So what's the product rule when you have three factors? Well, let's work it out, right? So let's think of this as a product of u and v times w. So by the product rule, we get u times the derivative of v times w plus the derivative of u times v times w. Right? So now we just apply the product rule again to v times w, right? So that's going to be u times v times the derivative of w plus u times the derivative of v times w. And then we still have the last factor. It's going to be the derivative of u times v times w. So if you notice, you're just essentially multiplying two of the factors times the derivative of the third. Right? So now we can take the derivative of f of x. So the derivative is going to be u times v, which is just 2x cubed plus 3x times x minus 1, times the derivative of w. The derivative of x plus 4 is 1 plus 0. Right, so that's just 1. Plus u times the derivative of v. So here's u. And the derivative of v is also 1. Times w, which is x plus 4. And finally, the derivative of u is going to be 6x squared plus 3 times v times w. So x minus 1 times x plus 4. Right, and there you go. That's the derivative. Not pretty, but if you want to multiply it all out, you can. And maybe we should do that. So this will end up being, let's see, 2x to the fourth minus 2x cubed plus 3x squared minus 3x plus 2x to the fourth plus 8x to the 3 plus 3x to the 2 plus 12x. And boy, I guess I'm going to do this first. So this is just x squared plus 3x minus 4, and then multiplied by the 6x squared plus 3. So we're going to end up with 6x to the 4 plus 18x to the 3, and then minus 4x squared, or sorry, 24x squared, plus 3x squared, plus 9x minus 12. So we're going to get, let's see, 2x to the fourth plus 2x to the fourth, that's 4x to the 4 plus 6x to the 4, so that's 10x to the 4. And then for the exponents of 3, we have negative 2x cubed plus 8x cubed, so that's 6x cubed. And then 6 plus 18 is 24, right? So 24x cubed. Let's try that again. And then the square term. So we have, I'll try it this way, 3x squared plus 3x squared is 6x squared. And then 6 minus 24 is going to be negative 18x squared. And then negative 18x squared plus 3x squared is going to be negative 15x squared, right? Okay. And then the x terms, we have negative 3x plus 12x is 9x. And then 9x plus 9x is 18x. And then the only constant I think we have here is the negative 12 at the end. So there it is, right? But on the other hand, if we were going to multiply all this out, why didn't we just multiply this out, right? So there's a much easier way to do this. Rather than use the product rule, it's just to multiply out f of x first and then just use the sum rule, right? So let's do it that way, and I'll show you it's much easier than using the product rule essentially twice here. Okay, so here's the original function. Again, we want to take the derivative, but before we take the derivative, why don't we just multiply this out first? And I'm going to do this pretty much in a similar way that I did when we already took the derivative. I'm going to multiply this out first to give us x squared plus 3x minus 4. And now, let's just multiply 2x cubed times x squared plus 3x minus 4 plus 3x times x squared plus 3x minus 4. Last time I kind of did that all in my head, but it helps to write it out in this case. So we're going to get 2x to the 5th plus 6x to the 4 minus 8x to the 3 plus 3x to the 3 plus 9x squared minus 12x. And the only things we have to combine here are the negative 8x cubed plus 3x cubed, which is negative 5x cubed. Negative 5x cubed, right? Okay. So be careful, because this is not the answer. This is the original function. This is still just f of x, just multiplied out. Right? The original question was to find the derivative. But now in this form, taking the derivative is, well, should be pretty easy at this point, right? You're just using the rules from section 2.2, namely the sum rule, constant times function rule, and the power rule, right? So the derivative of 2x to the 5th is 2 times 5x to the 4. So 10x to the 4. The derivative of 6x to the 4 is 24x to the 3. The derivative of negative 5x cubed is negative 15x squared. The derivative of 9x squared is 18x, and the derivative of negative 12x is negative 12. Right. And then there's the derivative. Compare that to what we had earlier, doing it the long way. And you can see we have the same answer, right? But considerably easier, at least taking the derivative, right? Here the hard part, or the tedious part, was multiplying it out first. It's, it's a lot of work, but it's worth the effort, because then taking the derivative of this, right, is much easier than taking the derivative of this using the product rule, in my opinion, anyways. So 2 ways to get at the answer. And of course, if you did use the product rule, you're welcome to leave it like this, right? Although if they do ask you to simplify it, obviously you should multiply it all out and simplify it. But if you're going to do that, you might as well have just do that right away, simplify it first, and then take the derivative. Right. So yeah, as a general rule, simplify first, then take the derivative. Okay, number 11, and this one should be fairly routine, but it's worth going through. So we have cosine of t divided by t, and once again, they just want the derivative, so they want f prime of t. Now, unlike in the previous problem, there's really no good way to simplify this. So I would just use the quotient rule here, right? So low d high minus high d low over the square of what's below. So t squared in the denominator. So denominator times the derivative of the numerator. The derivative of cosine is just negative sine. Oops, not plus, but minus numerator times the derivative of the denominator, but the derivative of t is 1. So you're just going to end up with, let's see, we can pull out the negative again. This is going to be t sine t plus cosine t. divided by t squared. And feel free to leave it like that. Or if you split it up, you can write this as negative, cancel one of the t's here. So this is just going to be sine t over t, negative sine t over t, and then minus cosine t over t squared. And that's okay too, I guess. Okay? Yeah. Now, some of you might be thinking, well, of course I can simplify this, right? I could have written this as t to the negative 1 times cosine of t. Absolutely. So if you'd rather think of it this way, now you're just using the product rule instead of the quotient rule. So let's see what we get, right? So first, times the derivative of the second, plus second, times the derivative of the first. And the derivative of t to the negative 1 is negative 1t to the negative 2. Right. So we're going to have negative t to the negative 1 times sine of t, and then minus t to the negative 2 times cosine of t. Now, if you want to make them into positive exponents, right, t to the negative 1 is just 1 over t. So this is negative sine t over t, and then minus cosine of t over t squared. And you can see it's the same answer we got using the quotient rule. So if you thought, using the product rule was easier than using the quotient rule, then okay, that's fine. I mean, in most cases, the quotient rule will probably be easier, but because the denominator is just a single term, a monomial, it's easier to write that as t to the negative 1 rather than 1 over t. But either way gets you there, right? Okay, so number 14 is also not a particularly easy one, so we can go through that one too. Find the slope of the graph at the point pi over 6, 1. So x is pi over 6, y is 1. And the graph is y equals 4 plus cosecant x over 8 minus cosecant x. Okay, so the first thing I would say here is that their language is a little bit sloppy here. It's not the slope of the graph, it's the slope of the tangent line to the graph, right? So you have some graph, right? We don't say it's this, the slope at x equals 2. We say it's the slope of the tangent line at x equals 2, right? But, okay, so slope of the graph, slope of the tangent line to the graph, same thing. All right, so how do we do that? Well, the slope of the tangent line is the derivative. So we simply have to take the derivative. And it doesn't look like we're going to be able to simplify this. Again, you could write it as a product, but I don't think that's the way to go here. I mean, yeah, writing it this way doesn't make it any easier, in my opinion. In fact, you won't be able to do this until you get to the next section, because taking the derivative of this requires the chain rule. And if you're only in section 2.3, you've never heard of the chain rule yet. So, yeah, so rather than do this, there's another way we can simplify this. And it's just, I mean, at this point you should know the derivative of cosecant, right? It's negative cosecant cotangent. But you probably remember the derivative of sine. You better know that, right? It's just cosine. So there's something we can do here to change this to sine instead of cosecant. And that's just to multiply numerator and denominator by sine of x. Right? So what does that do? If we distribute the sine x, so we're going to get 4 sine x plus cosecant x times sine x all over, you're going to get 8 times the sine of x forgot a parentheses here. And then minus cosecant x times sine x. Excuse me. Right. So you might, at this point, you might say that doesn't make it, that doesn't look any easier, right? In fact, it looks like I made it worse. Except remember that cosecant is just 1 over sine. So cosecant times sine is just 1. So this equals 1, and this equals 1. So we can write y as just 4 times sine x plus 1 over, all over, 8 times the sine of x minus 1. Right. It's still just y. We didn't take the derivative yet. But in my mind, this looks easier than the original one with involving cosecant. So that's the way I would think of it. Now we can take the derivative just using the quotient rule. So it's the denominator squared. Right. And then we have numerator. I'm going to have to write small here. Oh, sorry. Denominator times the derivative of the numerator. So the derivative of the numerator is just 4 cosine x minus numerator times the derivative of the denominator. The derivative of the denominator is 8 cosine x. And now we just expand all that out in the numerator. Don't bother expanding the denominator, right? So for the numerator, we're going to get 8 sine x times 4 cosine x. So that's 32 sine x cosine x minus 4 cosine x. Right. And then minus, let's see, 4 sine x, 8 cosine x is 32 sine x cosine x. And then minus 1 times 8 cosine x, so minus 8 cosine x. So this is looking a lot better already. Well, I don't think I need that much space here. So the denominator stays the same, 8 sine x minus 1 squared. So look what happens in the numerator here. We have 32 sine x cosine x minus 32 sine x cosine x, which is 0. Right, so these just add up to 0. And then negative 4 cosine x minus 8 cosine x is negative 12 cosine x. So that's it. That simplifies, that's about as simple as it gets here, right? Negative 12 cosine x divided by 8 sine x minus 1 quantity squared. Now that wasn't the question. Let's go back to the question. Find the slope of the graph at the point when x is pi over 6 and y is 1. So the slope is a number here, right? So we're looking for m as a number. And it's just going to be the derivative when we plug in x equals pi over 6. Right? Again, where did I get the pi over 6? That was in the question. Pi over 6 is x. Y is 1, although we don't have to know y here, but we do have to know x is pi over 6. All right, so the numerator is just negative 12 times the cosine of pi over 6 divided by 8 times the sine of pi over 6 minus 1, the whole thing squared. All right, so here's where you have to remember your trigonometry. Remember your unit circle, right? Cosine of pi over 6 is square root of 3 over 2. Okay. Sine of pi over 6 is 1/2. All right. So to simplify this a little bit more, negative 12 divided by 2 is just negative 6. So negative 6 square root of 3. And then 8 times 1/2, 8 divided by 2 is 4. So we get 4 minus 1. Right? 4 minus 1 is 3. Don't forget we have to square it though. So 3 squared is 9. And then 6 over 9 reduces to 2 over 3. Right? So this is 2 times 3 times square root of 3 over 3 times 3 times, well, times 1. So the 3's cancel. 3 divided by 3 is 1. Oops. And that leaves us with a grand total of negative 2 square root of 3 over 3. That's just the negative sign in front, right? So yeah, the slope is negative. The slope of the graph is negative 2 square root of 3 over 3. So that's my m. Right? And that's all they wanted. I don't think they asked for the equation of the tangent line. If they want the equation of the tangent line, right, then you're using the point slope form. Or you could also just use y equals mx plus b. Here's your m, and then your x0 and y0 are the pi over 6 and the 1 that they gave us, right? So yeah, x0 is pi over 6, y0 is 1, and m is the negative 2 square root of 3 over 3. All right, so like I say, not an easy problem, but one that I think was made a little bit easier by first simplifying to put it in terms of sine instead of cosecant. And that's just my personal preference. You're welcome to take the derivative of the original form, but then, you have to remember the derivative of cosecant, which you should know, but it's easier to forget that than to forget the derivative of sine is cosine. Okay. And I guess I'll do one more. Find the second derivative of f of x equals x times sine x. Okay, so I tend to like these problems. Right? So in order to find the second derivative, we have to take the first derivative. And there's not a lot we can do to simplify this, so it's as simple as it gets. The issue is it's x times sine x, so that's a product rule, right? So first, times the derivative of the second, the derivative of sine is cosine, plus second, which is sine, times the derivative of the first. The derivative of x is 1. Okay, so that's the first derivative. Again, there's not much we can do to simplify it, so I'll leave it as it is. But they want the second derivative, so we have to do this again. So let's start with the first term here, x times cosine x, right? We have to take the derivative of x times cosine x plus, and this is just the sum rule, right? Plus the derivative of sine. Okay, so that's the easy part. The derivative of sine is cosine. But before we do that, let's take the derivative of x times cosine x. And that's, again, using the product rule, right? So x times the derivative of cosine, which is negative sine, plus second, which is cosine, times the derivative of x, which is 1, plus the derivative of sine is cosine. Right? So we're left with, let's see, a positive x times a negative sine x is negative x times sine x, plus, well, cosine x plus cosine x is just 2 cosine x. And I think that's about it, right? So that's the second derivative of f. And we can just leave it like that, or just change the order, right? You can write 2 cosine x minus x sine x. Either way is fine. Okay, so that's product rule and quotient rule, section 2.3.